My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 238. In this lecture, I will continue my discussion on dimensionality reduction. What is our problem? Let me assume my original data set size is 784 dimensions. I will convert into d dash dimensions such that I must explain 90% of the variance or 90% of the information. I must identify, here our problem is identifying correct d dash. This is the problem which has got a very good significance in most of the machine learning problems. We have a beautiful formula, what it is, lambda 1 plus lambda 2 plus so on lambda d dash. This I already discussed in my previous lectures by sigma I equal to 1 to d. Here d means 784 total dimensions. Here my d is 784 dimensions. I want to reduce it to d dash. Therefore, let me say this is lambda I. I want this number to be 90%. That is 0.9. We want to find d dash such that this ratio is 0.9. 90% of the information or variance is explained by using PCA, or 90% of the information or variance is retained by using PCA. Let's go and see same data set on which I am working, that is MNIST data set. Here I want to compute all 784 components. You can understand why am I calculating all these 784 components on my sample data. We will try to understand. Bear for few minutes. Here we use same scikit-learn package or library to compute principal component analysis. Now, what I'm doing here is I'm saying number of components is 784, which means I want a 784 dimensional transformation. So I'm going from 784 dimensions to 784 dimensions. What is the reason? Just bear for few minutes, you can understand real significance. Let me explain this simple code. Here what we have, there is something like percentage underscore variance underscore explained. This we will try to understand. Again, I am requesting you to go through my previous lectures to understand these concepts. What is this? What is this percentage underscore variance underscore explained? It is simple. It is lambda 1 by sigma lambda I, comma lambda 2 by sigma lambda I, comma lambda 3 by sigma lambda I, so on. That's what it says. That's what this formula says. Now, what about this cumulative sum? What is this? Where this cumulative variance explained? I can say this is cumulative variance explained. What does it mean? This means this is lambda 1 by sigma lambda I, lambda 1 plus lambda 2 by sigma lambda I, comma lambda 1 plus lambda 2 plus lambda 3 by sigma lambda I, comma so on. Anyway, this figure size, all these things I discussed in my data visualization classes. Just I am plotting this cumulative frequency with the line width 2 pixels. My x label on x-axis I am taking number of components. On y-axis I am taking cumulative underscore explained underscore variance. Now we will plot this graph so that you can understand the significance. Just let me say this one. Let me say like this. For example, let me say my d dash, my d dash is 100. What is our question? Just let me rewrite question. My original dimensions are 784 dimensions. I have to convert into d dash dimensions such that, let me say, if I want to retain 90% information, what is my d dash? That is question, d dash dimensions. Let me say like this. Let me assume my d dash is 100. This is 100 number of components. Just go on this particular plot. Where is this point? Yes, this is, can I say it is in between 0.6 and 0.8? 0.6 and 0.8 means it may be 0.75. Will it be 0.75? Can I say, or something like 0.8? Let me say roughly it is 0.75. Roughly it is 0.75. What does it mean? What does it mean? 75% of my variance, 75% of my variance is explained by d dash. What is my d dash? 100 dimensions. Original data size is 784 dimensions. By reducing to, if you stop 100 eigenvectors, I can retain 75% of my variance, isn't it? My d dash, if you say 200, what's happening? 200 means somewhere here, isn't it? 200, what does it mean? 200 means it is in between 0.8 and 1. Can I say this is something like 0.95? Can I say this is 0.95? Yes, if it is 0.95, what does it mean? 95% of the information it can explain. 95 information can be retained if I make use d dash is equal to, let me say, 200, isn't it? Now, let me say, if I say, if it is something like 350, let me say some 350. If it is some 350 means somewhere here, 350 means what? It is almost 350. If it is somewhere, if I take my d dash value is 350, it is almost like 0.95. It is almost like 0.95. What does it mean? 95% of the information or 95% of variance, I can say 95% of variance can be retained, or 95% of the variance can be explained by using how many dimensions? 350 dimensions, isn't it? It has got very good significance in many machine learning data reduction applications. By using, there are 784 dimensions. By using just 350 dimensions, I am able to retain 95% of information. I am able to explain 95% of the variance. This is a simple graph by which you can always identify d dash. Just let me go to Jupyter Notebook and let me show the same code. What is this? It's simple code on same Jupyter Notebook. This is a Jupyter Notebook on which I am spending a lot of time from my past few lectures. Just see this PCA. I will provide this IPython notebook in Google link. PCA.n_component 784. Same thing. Just let me plot this one. If I plot, just see this one. What will I get? This plot. This, what it indicates, just see, this is the graph. This graph is useful to identify your d dash. If you want to transform from d-dimensional data to d-dash dimensional data, if you want to identify percentage of the information, percentage of the variance explained to what is the corresponding D dash you can identify from this particular graph. This is I can say this is my my last lecture on principal component analysis. In my next lecture I will start discussion on Tisney. It is one of the beautiful technique, Tisney. This Tisney has got so many advantages compared to your principal component analysis. In the case of principal component analysis, we have got one drawback. If you want to visualize data by using principal component analysis, we have seen so many overlaps are there. In order to overcome that difficulty, we have a good machine learning technique known as Tisney, which I will discuss in my next lecture. Thank you very much.